In this video, we're going to explore the topic of deadband and some of the ways that it affects on-off controls. Working from our FactoryIO simulation software, let's go to Scenes, and we'll pick from our Scenes level control. Once our level control app opens, we'll go to File and Drivers, and we will select the driver of Control.io. Control.io is going to be our soft PLC that allows us to program to our simulator in the absence of a real PLC. In order to test the concept of deadband, we need to create logic that simulates deadband in an on-off controller. So we will be working from our tags initially to pull in from our simulator the set point. This set point is a dial that sits in the control panel that will allow us to feed a value in to drive our logic and respond to changes of set point. Next, we're going to create a source, a numerical source that represents the desired deadband of this system. So clicking on the numeric input adjacent to the numeric input and slider bar, it will highlight it, allowing us to come down and give this thing a name. We will call it deadband. The deadband will be from 0 to 5. So with our deadband, we'll use it in conjunction to the set point, and from our functions we will grab some math functions to add and subtract the values from our set point to create our deadband. So what we'll do is we'll take the set point and we will both add and subtract our deadband to create a plus and minus range to allow our fill valve to respond to. So in order to respond to our level change in our tank, we will bring in the level meter, and the level meter will be compared against, and to compare we'll use our rational and equality statements. So we'll bring in our comparator to be greater than or less than set point plus or minus deadband. So what we have so far is our set point, in this case plus our deadband. So when our set point, or I should say when our level meter is greater than our set point plus deadband, we'll make a decision to turn off our valve. Down below here, our set point minus our deadband, when that becomes less than the level meter, that will become our signal to turn on our fill valve. Next, I'm going to bring in some indicators so in our simulation environment, we can see the process variable on the panel in addition to the set point. Next, we're going to find a set reset block which will allow us to assign from our Boolean decision whether we're above or below set point plus or minus deadband to assign the value to our fill valve to control the filling of our tank. So from our outs, we will either set or reset. In this case, it'll be the assignment of values, where the assignment of our numerical value of 0 and 10 will be the values to fill or stop filling our tank. Next, I'm going to come over and find the assignment instruction. That's going to be found under Extra and Assign. So from here, working through our logic again, when our set point plus our deadband makes an upper limit, and when our level meter is greater than that upper limit, we will choose to set the value. In this case, when we set a value and the output assignment goes to in on our assign, when in becomes true, it's going to pick the value on PT2. In this case, we're wanting to close our valve, where the tag we need to assign to our valve is going to be the tag fill valve. Then following the bottom logic, if we have our set point minus our deadband makes a lower level, and when the level meter is less than that value, it will reset, and when reset makes our assign go false, and it will assume the value on PT1, which will take our fill valve and open it completely. So to see this work, I'm going to start our code. I'm going to go back to our FactoryIO, and I will start the simulator. So going down to our set point, I will dial up the set point to say somewhere around 5. I will go back, take a look at our code, and what we can see is I have a set point of 4.98. Our level meter is working up to that value. When it gets greater than that value, it will set the assignment for 0, and we've just seen that. And now it has settled out and gone over a little bit to 5.2. So in order to really test the effects of deadband, we have to put a disturbance in this system. We're going to do that by clicking on our discharge valve and manually opening it. And what we will see is that the discharge valve opens and the level of the tank decreases. Our logic responds to it, but it responds to it in such a way that when we are above or just below set point, it starts to open or close our fill valve. So going back to logic, we can see that with no deadband of 0, either greater than or less than our value on our level meter, we assign we assign 0 or 10 to our fill valve, closing it or opening it completely. So here I'm going to add just the smallest amount of deadband of 0.5, and when we go back to our tank, just that little deadband allows us to settle out. The tank drops below our set point, subtracting the 0.5 before allowing it to start to fill, and then we're going to go 0.5 above our set point of 4.898 before it stops filling again. And what we'll see is that when the assignment is true here, we will be taking our value of 0 and push it through. When we go below our set point minus 0.5, we will see it will start to fill, and we see that value get pushed to the fill valve again. And this will continue to operate in an automatic fashion, responding to the actual level meter of the tank. So if we come back here, and we can kind of speed up the process by making it discharge faster, and we will see that as the tank drops below the set point, subtracting the deadband, it will start to fill. It will fill for a period of time before reaching the upper limit, which is set point plus deadband, before shutting off. So having watched this a couple times, I'm now going to come back and I'm going to open up the deadband to a deadband of 2. So now what we'll see is that our set point of roughly 5, subtracting that, this will go all the way down to almost 3 before it switches back on. Likewise, it's going to go all the way up to 7 before switching off. So the process variable here went down to 3, and we're going to see how this is going to rise all the way to 7 before finally switching back off. So by widening the deadband, we have longer periods of filling and longer periods of emptying. And after a little while here, 7 plus, we will see this stop filling. And again, we will watch this go all the way down to our set point minus our deadband, which will put us somewhere around a 3 before we start filling again. So too narrow a deadband and the valve turns on and off very quickly, causing disturbances in the tank. A very wide deadband can cause longer periods of being on or off. So the application really determines what the rules are for what is acceptable. So we never want our tank to go empty, but we want to have periods where it's at a more stable level. A narrow deadband would make sense. If we can tolerate wider ones, we simply can increase that variable, and very quickly all the code adapts to it, allowing us to make a single change. So this has just been a quick example on some of the effects of deadband and how to make some of the logic to drive automatic on-off control.